I'm back. You're back. And guess who else is back? Oh yeah, there he is. Hanging out. Still chilling. Okay. So VH01, we're going to start getting into transformations of quadratic functions. Basically, how a transformation affects the look and feel of a quadratic. So a couple things that we need to establish first. The function f of x equals x squared is the base function, which is called the parent function. Okay? It's where all other quadratics begin from. And the parent function of x squared is very simple. The vertex is on the origin, and it sprouts out on both sides here. Okay? Now, a lot of the functions that we talked about, especially ones in vertex form, that's not it, right? They got a lot of other numbers in it. Specifically, when we talk about vertex form, and you have a vertex, like the opposite of this, exactly that. So I want to go very simple at first, and vertical and horizontal shifts are how we can start very simply. So there's going to be some rules that we talk about. So f of x plus k, that is a vertical shift. And because it's a plus k, it's a vertical shift up k units, basically however many units k would be. So for example, let's say that we have this parent function, right? And we have f of x equals x squared plus 7. Okay, well, there's a plus 7 at the very end of the function, at the very right, just like that k was. That means that function, this function, was shifted up 7 units. So basically what happens is here, the vertex will go up 7 units and it'll still look the same way coming from here, okay? If it was f of x minus k, it's exactly the opposite. It would be a vertical shift down k units. So for example, let's talk about f of x equals x squared minus 2. Okay, so because the number value with the sign is at the very end of the function to the very right, that indicates the vertical shift up or down. In this case, it would be down 2 units. Again, same thing here, down 2. Okay, that is vertical. Okay, all vertical here. Now, let's talk about horizontal. And a horizontal looks a little funky, but it's the same process. So we're going to take the same parent function. It would be f of x equals, let's say, x minus h squared. Okay. Now the h represents the side-to-side shift. Okay. Now remember, think back to when we talk about vertex form. It's always the opposite of this, right? So in the last case, I think it was a -6, so it was actually a +6. Everything that happens inside parentheses of a quadratic function is what I like to call a liar. They are lying to you. It looks like one specific thing, like the negative sign here, you would think it would go to the left, but that's totally wrong. It actually goes to the right. So let's talk about a couple of examples here. So let's say I had f of x and the parent function was x squared, which turns into, through a horizontal transformation, let's say it went to f of x equals the quantity of x plus 3 squared. Okay, so you see the plus 3, hopefully you can see that. Okay, so you see the plus 3 here inside of the parentheses, but the rule is that it's always the opposite of what you really think it looks like. If it's inside parentheses, it's horizontal, and it's a liar. So plus 3 usually looks like a right 3. Wrong, it's a left 3. So this is a shift left 3, okay? Let's do 2 more. F of x equals the quantity of x minus 6 squared, okay? Well, it looks like a minus sign, but it's lying to you because it's inside the parentheses, which means it's horizontal, and it's not true. It's not telling the truth. This is plus 6, which means right 6. Okay? So it's right 6 units. We'll do 1 more. F of x equals the quantity of x minus 1 squared plus 3. So now I'm throwing both of them in there, right? So let's talk about both transformations we talked about. Very end of the function. So, okay, let me back up a second. If everything that's inside parentheses is a liar, it's the opposite of what you think, everything on the outsides of the parentheses are truth tellers. They say or do exactly what they look like they do. The plus 3 is a truth teller. It really means plus 3, and it's vertical. It's going up 3. The inside, however, it's a minus 1. It's horizontal, but it's a liar. It looks like a left 1 because you usually associate negative with left, but it's not. It's right 1. So this function is right 1, up 3. I'm writing totally crooked. Okay. Now let's talk about what Desmos will show us. keep in mind, we had this one function on the last video. Let me probably go to vertex form here just so we can see it a little bit better. This was x minus 6 squared minus 70. Okay, so this was the function that we talked about before. I just wanted to put in vertex form so you could see it a little bit easier. Now, if we focus just on the equation itself, opposite of this, exactly that. Well, remember what I said. Every number that, or sign and number that's outside of the parentheses is vertical and a truth teller. Well, if it's a truth teller, the minus sign indicates down. So down 70. Take a look at this function. If we started with the vertex at the origin, it does look like it went down 70. So that was one of the physical transformations that occurred. The minus 6 in here, every single time you see something inside parentheses, it's horizontal and it's a liar. You would normally associate a negative sign with left, but because it's a liar, it's right. So take a look what happened here. The vertex moved to the right of the y-axis. So I went right 6, down 70. And we knew that the vertex was the opposite of this and exactly that anyway. So that might be one way to help you remember it. Opposite of this, exactly that. So those are, in a nutshell, vertical and horizontal transformations. They are shifts. We're talking about vertical up or down, horizontal right or left. And you'll have time to practice this. Let's see where tightness with the bone. Because I know that's the only reason you tuned in. How's that bone, buddy? You didn't even get anywhere. Hey, say goodbye to everybody. Bye-bye.